Hello students, so welcome to my next online class. So in today's class we are going to a new chapter, that is magnetism. So already few topics has been excluded from this chapter. So I hope you have downloaded the ISC class 12 physics reduced syllabus. So while I am taking the class, you find that just once you cross check whether the topics whichever is there in your syllabus, I am going through those or not. So already I have marked those topics, and most probably I will be going through that topics, but if in case if it is any left out, you will just let me know. Okay, so let's start our class today. Magnetism. You see, this magnetism, the magnet is not a new term for you. So magnets are those substances which has an ability to attract other magnetic material. Like whenever a magnet is brought near a magnetic material like iron, it gets attracted, right? So magnets have a two poles, that is north pole and south pole, and the poles are not separable, means we cannot separate the poles. So whenever you cut the magnet or you slice the magnet, you will find that there are two poles exist there. So also the magnets have some properties like dielectric properties. So whenever a bar magnet is tied with a string, and when you just suspend it, you will find always it rests in north and south direction. So this is a magnetic property. Also, like poles, you see they repel each other, and unlike poles they attract each other. This also we know from our junior classes. And also we know that whenever a magnet is brought near to other magnets, they attract or repel. So why they attract or repel? Because they create a magnetic field around it. So whenever any magnet is brought near to that magnet, it gets attracted or they get repelled, right? So here in this chapter, in class 12, we'll go through this magnetism chapter much more detailedly. Like what happens to a charge when it is placed in a magnetic field. Okay, so what is the force on that charge when that charge is moving in a magnetic field? So how can we accelerate a charge by using a device called cyclotron? So what are the units of magnetic field? Now you say that if a body, if a hollow surface is there, and if we place a magnetic material or a magnet inside that hollow sphere, so how much magnetic flux will be coming out? Like we have seen in an electric flux. So similarly we will see that how much magnetic flux has been coming out. So this type of questions answer will get in this chapter. Okay, so I am just starting from very basic so that you can have a hold on this chapter, and it's scoring also, and in some cases it becomes complex, but if you are very attentive and if you are going through the topics very nicely, this chapter is very scoring. Okay, so magnetism. What is magnetism? You see, the region of space in which a compass needle placed at any point stays in a definite direction is called magnetic field. So this is the other definition of magnetic field. The first definition which I have told you, magnetic field is defined as the space or region around a magnet. Whenever another magnet is brought near to it, either it will get attracted or repelled. So this was one definition, and the next definition is that suppose there is a region and you have taken a magnetic compass. So magnetic compass needle, when you are taking to a place where there is already a magnet placed, so it will show a definite direction. That means north will point towards north and south will point towards south. So if that magnetic compass rests in a definite direction, that means it points to a definite direction, we say that there is a presence of magnetic field. But if it moves in any direction, it don't show any fixed direction, then we say that there is an absence of magnetic field. So likewise we can define magnetic field also: the region of space in which a magnetic compass needle placed at any point stays in definite direction is called magnetic field. That means wherever a magnetic compass is resting and it is showing a fixed direction, then that means it has a magnetic field around it. And if it rests in any other direction, if it shows not a fixed direction, then we say that there is no magnetic field, or there is an absence of magnetic field. Okay, so the magnetic field is a vector quantity, right? Like electric field is a vector quantity, magnetic field is also vector quantity. It starts from north pole and terminates at south pole. That means magnetic field lines starts from north pole and terminates at south pole. It is denoted by B arrow. That means as it is a vector quantity, so it is denoted by B, and up ahead there is an arrow. The magnetic force on a charge Q moving in a magnetic field. Now you see, I have placed a charge, that is Q charge, in a place where there is a magnetic field. So the question is that how much force will be acting on that particular charge, that is point charge. Okay, that means that is given by F equals to BQV sin theta. Okay, F equals to B is the magnetic field, Q is the charge, and V is the velocity. Okay, so whenever a charge is placed in the magnetic field, it will start moving. The charge will not be stationary, it will move from one place to another. So it will move with some velocity. That velocity is given by V. And sin theta means here what is the movement of that object and the magnetic field. Okay, so movement means here velocity, in which direction the object is moving, and what is the magnetic field, whether it is perpendicular or it is parallel. So this is the term, this is the expression for force on a charge Q moving in a magnetic field. Now from this definition also we can define magnetic field. Okay, so you see B equals to F by QB sin theta. If you cross multiply, you will get this expression. Now when sin theta, when theta equals to 90 degree, that is perpendicular, that is magnetic field is perpendicular. Okay, the charge where you are placing there, that uniform magnetic field, that is perpendicular. That means theta equals to 90 degree, V is 1 meter per second. That means charge is moving with 1 meter per second. So if you place in place of V1 and sin theta, that means sin 90 is 1. So you will get F by Q. So from here also we can define the magnetic field. So magnetic field is defined as the force on a unit charge which is on a uniform or in a perpendicular magnetic field moving with a velocity of 1 meter per second. Okay, I repeat, magnetic field is also defined as force on a unit charge placed on a perpendicular magnetic field moving with a velocity of 1 meter per second. That means when it is moving with 1 meter per second and it is placed in a perpendicular magnetic field, then we say that force, that is B equals to F by Q. Okay, so next we will find what are the units of magnetic field. Now there will be a definitely, if any physical quantity is there, like we say that speed, that means it has a SI unit, that is meter per second, it will be having a CGS unit, that is centimeter per second. Similarly, this magnetic field physical quantity, it also has SI unit and CGS unit. So SI unit means here Newton per ampere meter. Okay, so it has 3 SI unit, but all the meaning is same, like means Newton per ampere meter or Weber per meter square or Tesla. So these are the 3 units of magnetic field. Okay, and CGS unit is Gauss, Gauss, Gauss. So 1 Gauss equals to 10 to the power minus 4 Tesla. Okay, so this is the relation between CGS unit and SI unit. Okay, so these are the terms for the magnetic field which you need to note down in your exercise book. So whenever 2 magnets are placed close to each other, there will be a force of attraction or repulsion. Now to understand this strength of magnetic field, we know there are magnetic lines of force. So magnetic lines of force are the imaginary curve which originates from north pole and terminates to south pole, and the tangent drawn from any point of that imaginary curve gives the direction of magnetic field. Okay, so this is the definition of magnetic lines of force. Like for example, if I say these are the 2 magnets, 2 bar magnets, this is north and this is south, again this is south and this is north. So definitely line will start from north and terminate at south. Okay, so these are the magnetic lines of force. Now if I draw a tangent from this point, if I draw a tangent, that means the direction of tangent will give the direction of magnetic field. Okay, so what do you mean by magnetic lines of force? So magnetic lines of force are the imaginary curve which originate from north pole and terminate to south pole. the tangent drawn and any point on the curve gives the direction of magnetic field. Okay, so it gives the direction of magnetic field here. So you see there are certain properties of magnetic field lines. First property saying that magnetic field lines of force are always closed curve. That means it starts from north and terminates at south, but internally it starts from, like for example in north and south, it originates from north and terminates at south here, but internally it is from south to north. So always it forms a closed curve. Next we find that they do not intersect with each other. So if numerous number of magnetic lines of force are there, they will not intersect with each other. Now we know the reason why they don't intersect. Similar as electric field lines. Okay, so if two magnetic lines of force intersect each other, then at a particular point of intersection there will be a two direction of magnetic field, which is not possible. Okay, so as electric field and magnetic field, they are vector quantity, so there should be only specified or fixed direction. So but if two magnetic lines of force, they intersect each other, at the point of intersection there will be two direction, which is not possible. So therefore they don't intersect with each other. Now here you see the magnets. Now when I have taken here two magnets, one magnet and two magnet, when the distance between two magnets is very small, that means magnetic lines of force will be maximum. That means we say that magnetic field is more. But as soon as that magnet is brought away from each other, that means as the distance is increasing, so number of magnetic field lines also decreases. So if the number of magnetic lines of force is more, then we say that magnetic field is stronger. If the magnetic lines of force field lines are very less, then we say that magnetic field is weaker there. Okay, so this is how these are the properties of magnetic field lines. So you need to remember the definition and at least three properties. Okay, next we will find that magnetic flux. So flux means anything which has an ability to flow. So like for example, if I have a surface here, okay, the total surface is S. Now if I have taken a small elemental surface, that is ds, okay, and suppose any magnet is placed in here, that means magnetic flux will be coming out from any direction, from each and every direction of that surface. So if I need to calculate how much flux is coming out normally through that small surface ds, so we'll calculate that this total magnetic flux is an integral of over a closed surface equals to b dot ds. Okay, so this is the magnetic flux. That means how much flux, how much magnetic lines, or the number of magnetic lines of force coming throughout a small surface normally is said to be as magnetic flux. Okay, so number of magnetic lines of force emerging from that surface is being expressed in terms of phi b. B means for here magnetic flux, phi we know that is a flux, how we denote here in the previous chapter also, phi e, that means electric flux, here phi b. So integration over a closed surface equals to b dot ds. So magnetic flux is a scalar quantity again, because it don't have any fixed direction. So when this flux is coming out, it is coming out from each and every direction. Okay, so just we are calculating how much magnetic flux is emerging from small ds here, but flux is coming from each and every direction, so it don't have any fixed direction here, therefore it is a scalar quantity. So SI unit of magnetic flux is Weber again, and CGS unit is what? Maxwell. And there is a relation between CGS and SI unit, 1 Weber equals to 10 to the power 8 Maxwell. Okay, so this is the relation between SI unit and CGS unit. So these notes also you need to write down. So the next topic we have here, you see, magnetic flux density. So when we say magnetic flux density, it is same as this magnetic field strength. Okay, so just we need to divide that magnetic field strength to that of magnetic flux to that of area. Okay, the normal magnetic flux passing through a unit area is called magnetic flux density. That means just now we have seen phi b equals to bds. So when this phi b, when you divide by a, that means area of cross section, that is unit area, then we say that that is magnetic flux density. Like in previous chapter we have seen a bar magnet. So what is the magnetic moment, or in the, you see, like, so electric dipole in the previous chapter in equatorial and Bourdon position we have derived the formula. Similarly we have here magnetic field. Okay, so mu naught by 4 pi 2m by r cube, where m is the moment here. Similarly at equilateral point, what is the magnetic field due to a bar magnet? That is mu naught by 4 pi m by r cube. So this expression you need to remember. Like in previous chapter we have learned torque equals to P cross E. We have here M cross B, where M is the magnetic strength, okay, or magnetic moment you say here. Potential energy of a magnet is minus mb or minus mb cos theta. And tangent law is given by tan theta equals to Bm by Bh. So Bm is the magnetic field in vertical direction and Bh is the magnetic field at horizontal direction. So we have Earth's magnetism. Let us consider at a certain point of Earth we have placed one magnet. That magnetic needle is making a theta with the horizontal magnetic field of Earth. Okay, now from this triangle if I find tan theta equals to P by B. So our P means here Bm means here actually it is the BV here. This is the Bm. So that means tan theta equals to P by B. So in place of P what we have? Bm. In place of B we have Bh. So Bm by Bh. Okay. So deflection magnetometer and tangent galvanometer are based on tangent law. So this is the tangent law. Okay. So Earth's magnetism, when we say that Earth behaves as a magnet and its magnetism is assumed due to the interaction of charged particles of Earth. That means in our atmosphere there are a few charged particles, and due to that movement of that charged particles, magnetism is being created on Earth. So this is the reason due to which our Earth behaves like a huge magnet. So there are a few terms you need to remember, that is angle of declination. The angle between geographical and magnetic meridian plane is called angle of declination. Angle of D means it is the angle made by resultant of magnetic field B with the horizontal. Like for example, see this diagram. You have placed one magnetic field here. It is making angle theta. BE means Earth's magnetic field, right? So the angle between geographical and magnetic meridian. So our Earth also has a meridian. Magnet also has a meridian. So the angle subtended between geographical and magnetic meridian is called angle of declination. And the angle subtended between resultant magnetic field and with the horizontal, that is called angle of dip. Okay, both terms are different here. So horizontal magnetic field is given by Bh equals to Be cos theta. See this triangle. From here if I need to find here cos theta equals to curly brown here, that means B by H, Bh by Be, right? So if you cross multiply you will get Bh equals to Be cos theta, Bv equals to Be sin theta. Okay, now if you divide this equation in 1 and 2, so Bv by Bh, again what we will get? Tan theta, that is the tangent law. So these notes I will be giving you, okay? So these are the terms also you will be remembering nicely. Okay, so try to understand the terms. So just you have to mug up these terms, so they give as it is. Okay, so you try to mug up and try to relate well, then only you will remember. Okay, so until and unless you understand it, so it will be very difficult for you to keep it in your mind. Okay, so I will be giving the notes in your WhatsApp group, so you will prepare notes from here. The important terms also you will be writing in your exercise book. So for today's class only this much. Thank you.